Okay, this is review A, 11 through 20. On number 11, you're given the function the square root of the absolute value of x minus 3. This is a function that I would probably make a table to get an idea of what the graph looks like. I started with x is 3 because I knew that would give me 0 for my root. And then what I did was choose values around that that would give me easy y values to graph. So -1, 2, 4, and 7. If I plug in -1 minus 3 is -4, the absolute value of -4 is +4, and the square root of 4 is 2. Again, you could choose any values. 3, your root is usually the easiest way to start, but you could choose anything around that. You just might not get an easy whole number to graph. But just keep picking values until you get something that you can put on the graph. So I graphed these points, and I connected the dots, and it looks something like this, which makes sense because our root curve is kind of curved. Our absolute value looks the same left and right of the vertex there. So now let's look at the answer choices. I'm looking for a statement that is true. F is continuous but not differentiable at 3. Well, it looks like 3 is a cusp, so I would say that that is true. F is differentiable at x equals 3. Well, it's a cusp, so no, false. F is not continuous at x equals 3. Well, it has a value, 0, so that's false. The limit as x approaches 3 of f of x is not equal to 0. Well, y is approaching 0 from the left. Y is approaching 0 from the right. So the limit is 0. X equals 3 is a vertical asymptote. There is no vertical asymptote, so that's also false. So A is our final answer. Okay, on number 12, we're using u substitution, and we're just going to set up the integral. We don't actually have to solve it. So let's set up this integral. We've got u is equal to the square root of x minus 1, which I'll write as x minus 1 to the 1/2. du then would be 1/2 x minus 1 to the negative 1/2 times the derivative of the inside, which is just 1, dx. And let's rewrite that as 1 divided by 2 square root x minus 1. Okay, I'm going to move the 2 by multiplying by it. Okay, so I have 2 du is equal to 1 over the square root of x minus 1 dx. Okay, we also need to find u of 5 and u of 1. So if I plug 5 in for x, I have 5 minus 1, which is 4. The square root of 4 is 2. Plug in 1. 1 minus 1 is 0. The square root of 0 is 0. So I have the integral from 0 to 2, so I can go ahead and eliminate anything that doesn't have that. And I need to have a 2 out front, so let's just set this up. We've got 2 times the integral from 0 to 2. We can actually go ahead and eliminate the other 2 as well. Let's just double check though. E to the root x minus 1 is u, and then du is 1 divided by root x minus 1 dx. So we have done the problem correctly. We're on letter C is the final answer. Okay, 13. The function f is defined by this piecewise function here. What is the value of the integral from 0 to 4 of f of x dx? Okay, so it might help you to graph it, but though you don't have to. We've got y equals 1 all the way until 2, and then y equals 2x minus 3 when x is greater than 2. So the y-intercept there would be -3, but I'm not going to draw it because the function doesn't exist less than 2. So -3, I'd rise 2, run 1, rise 2, run 1, and here that piece would fill in the hole. So this is what the graph looks like, and I want to know the area or the integral from 0 to 4. So you have a couple of options here. You could find the area of the 2 rectangles and then add it to the area of the triangle, or you can just set up the integral as 2 different integrals. We can go from 0 to 2 of 1, and the integral from 2 to 4 of 2x minus 3. Okay, the antiderivative of 1 is x. The antiderivative of 2x is x squared. 2x squared over 2, the 2's would cancel, minus 3x. And now we plug in our values. So 2 minus 0 plus 16 minus 12, I'm plugging in the 4, minus 2 squared is 4, 2 times 3 is 6. Okay, so I have 2 plus 16 minus 12 is 4, minus 4 minus 6 is -2, so plus 2, and that gives me 8 for my final answer. Okay, on number 14, it says if f of x is equal to x squared minus 4, and g of x is equal to 2x minus 1, then the derivative of f of g of x is equal to, at x equals 4 is. So let's start by finding f of g of x. This is a composite function. So we just take out the x's and put g in its place. So instead of x squared, we have 2x minus 1 squared, and then keep the minus 4. Now the derivative, or f prime of g of x, is going to be 1/2 times the derivative of the inside, so 2x minus 1 squared minus 4 raised to the negative 1/2. And then we multiply by the derivative of the inside. So that's 2x minus 1 times the derivative of the other inside, which is 2. Okay, so again, I rewrote this as an exponent of 1/2, and then I brought that down, subtract 1 from the exponent, keep the inside the same, then multiply by the derivative of the inside. Okay, now I want to know the value at x equals 4, so we can go ahead and plug in 4 here instead of simplifying everything. So we have 1/2, 4 times 2 is 8, minus 1 is 7, squared is 49, minus 4 is 45, 2 times 2 is 4, 8 minus 1 is 7. So now we have 28 divided by 2, which is 14, divided by the square root of 45. And I can reduce the square root of 45 a little bit. It's the same thing as the square root of 9 times 5, and the square root of 9 is 3. Okay, so I have 14 divided by 3 square root 5, which is d. Okay, let's look at 15. The graph of a differential function, f, is shown below. If g of x is the integral from 0 to x of f of t dt, which of the following is true? Okay, so the relationship between g and f is shown here. If I differentiate g, that's going to give me f of x. Again, when you see x's and t's mixed together with this integral here, I'm thinking fundamental theorem. So g prime is equal to the derivative of f of t, which is f of x. Okay, so this is also the graph of g prime. Okay, now we're looking at what happens when x is 6, so right here. So if this is the graph of g prime, then g prime of 6 is equal to 0, right? It crosses the axis there. This is g prime of 6 would be 0. Now I can also tell that the slope at 6 is negative. Well, the slope of the slope is g double prime. It's negative, so that's less than 0. Okay? Now thinking about the original g from g prime, it goes from increasing to decreasing. Remember that g prime represents the slope of g. So the slope of g is positive above the x-axis and negative below the x-axis. So if the slope goes from positive to negative, we have a maximum there. So g of 6 would be positive, or a maximum. Okay, so if we're going from least to greatest, it looks like we'd have g double prime, and then g prime, and then g of 6. Okay, so again, g double prime is first, then g prime, then g, so e. Okay, let's look at number 16. Okay, this is particle motion. It says that the position is t minus p, t minus q. Which of the following values of t is the particle at rest? So if it's at rest, that means that the velocity is 0. Okay, so to get from position to velocity, we have to differentiate. And this is a product, so we'll do the first times the derivative of the second, which would just be 1, plus the second times the derivative of the first, which is just 1. And remember here, t is the variable, p and q are constants. It tells us that in the problem. Okay, so that leaves us with t minus p plus t minus q. So that's 2t minus p minus q. And that's the velocity. So if the particle is at rest, the velocity is 0. So let's add the p and the q to the other side, divide by 2, and t is equal to p plus q over 2 when the velocity is 0. So let's see, that's answer choice D, p plus q over 2. Okay, number 17, the graph of f of x is shown. Which of the following could be g? Okay, again, you're given something that looks like the first fundamental theorem of calculus. So let's differentiate f and differentiate the integral. Okay, when you do that, f prime is g of x. Remember, you just plug in the x for t and you're done. Okay, so f prime is g of x. We're looking at the graph of f, so the slope of this graph is g. Okay, so which of these graphs could be the graph of g? Well, the slope of this graph is positive everywhere. So that means that g must have a positive y value everywhere. So answer choice A. Okay, let's look at number 18. This is the formal definition of derivative. So you have the limit as h approaches 0 of f of x plus h minus f of x. So this is f of x. Okay, and again, f of x plus h, this is x. So now what we need to do is find the derivative. This means derivative. So let's differentiate sine x and then plug in pi over 3. So the derivative of sine is cosine. If x is pi over 3, then we have f prime of pi over 3, which is cosine pi over 3. Okay, now you have to remember your unit circle a little bit here. Remember that pi over 3 is closest to the y-axis in the first quadrant, so I always do 3, 2, and 1. Okay, so cosine is the x value, so that is 1/2. Okay, on 19, we're given f of x. It says what points on the graph of f have the property that the line tangent to the graph has a slope of 1/8. So differentiate f, and that gives you the slope of f. Set it equal to 1/8 and solve for x. Okay, so in this case we need the quotient rule. So f prime is equal to the bottom times the derivative of the top minus the top times the derivative of the bottom over the bottom squared. Okay, so now I've got 2x plus 2 minus 2x over x plus 1 squared. So 2 divided by x plus 1 squared is the derivative. Now I want to know when the derivative, or the slope of the tangent, is an eighth. So we'll set 1/8 equal to 2 divided by x plus 1 squared. Okay, now I'm going to move this x plus 1 squared to the top by cross multiplying. Let's take the square root of both sides to get rid of the squared. Now remember, when you take the square root of a number, you put plus or minus, because I could square a negative and get positive 16 as well. Subtract 1, and so x is equal to 4 minus 1 and negative 4 minus 1. So 4 minus 1 is 3, negative 4 minus 1 is negative 5. So those are my x values. So let's look at the answer choices and see if there are any that include both x values. D has both. So if I plug 3 into the original equation, I'm going to get 3/2 out. If I plug negative 5 in for the original equation here, I'm going to get 5/2 out. So those are my 2 points. Okay, last one. Let f of x equal 2x plus 2 cubed, and let g be the inverse function of f. Okay, for this one you need to remember the rule that f of g of x equals x if f and g are inverses. Okay, so if f and g are inverses, then the composite f of g or g of f is equal to x. Okay, we also know that f of 0 is equal to 2. Well, remember that inverse functions mean you switch x and y. So g of 2 is equal to 0 if these two functions are inverses. Okay, we want to find g prime of 2. So let's start by differentiating this term here, or this phrase here. So we would have the derivative of the outside, which is f prime of g of x, times the derivative of the inside, which is g prime of x, equals the derivative of x, which is 1. Now, let's solve for g prime of x, because that's what my final answer is going to be. So we divide by f prime of g of x, divide by f prime of g of x. Okay, so g prime of x is going to be equal to 1 divided by f prime of g of x. Now let's just plug in our x value. Again, we're looking for g prime of 2, so we want to plug in 2. Now we know that g of 2 is 0, so we have 1 divided by f prime of 0. And we can find f prime of 0 if we go back to the original function, differentiate it, and plug in 0. So let's do that. F prime would be 3, 2x plus 2 squared times 2. So 6, 2x plus 2 squared. F prime of 0 means plug in 0 here, so that's 0 plus 2, which is 2. 2 squared is 4 times 6 is 24. So now I have 1 divided by 24 for g prime of 2. This is a problem that I've seen on many AP exams, and it really goes nowhere unless you remember this rule. If you see that f and g are inverses, you have to use this rule, f of g of x equals x. And then solve, differentiate it and solve for g prime. Plug in what you know.